Hello, IM2T. Sorry that I can't be there with you, but I hope this video finds you well and that you're able to learn from it. So we'll start off with the invitation. So make sure you do get the invitation from the sub. So invitation number 1, notice and wonder. What do you notice? What do you wonder? So take a minute, pause the video now, and just write down a few things that you notice. All right, so a few noticings. Okay, you notice that there are parallel lines. Right, lines AC and MN are parallel. You might also notice that if you have a set of parallel lines, there's a trapezoid. So quadrilateral AMNC is a trapezoid. You might also notice that there's a triangle that forms. There's a lot of different things you can wonder. Maybe one thing you wondered is also, is this triangle similar to this triangle? Maybe you noticed that. Maybe you knew the answer to that. Yeah, there's a lot of different things. But just hold on to those thoughts as we move on to invitation number 2. Right, these are the plans for a vegetable garden that a school is designing. And the scale is 1 unit to 2.8 feet. So write at least 3 equivalent ratios or equations using lengths from both the diagram and the full-size render. So we know that 3 to 4 will be equivalent to 8.4 to 11.2. Because if this is a scale, if this is 3 units long, then the actual garden is going to be 3 times 2.8, and 3 times 2.8 is 8.4. And then same with this 4. Multiply that by 2.8, you'll get 11.2. So that's 1 equivalent ratio. If you multiply 5 by 2.8, you're going to get, sorry, this one is 11.2. And then multiply 4 by 2.8, you're going to get, all right, we should write this out. Sorry, this is 14, this is 11.2. So we can also write 4 over 5 is 11.2 over 14. We could write 3 over 5 equals 8.4 over 14. So there's a lot of different things you could have written down. Yeah, but all of them are equivalent ratios. All right, so that is your invitation. So hopefully this is a good reminder of how to create ratios. And then just a few things about these parallel lines. All right, now you can ask for the notes from the sub and move on to the day 4 notes. Hello, IM2T. Welcome to day 4 of the notes. So after today, we'll be done 40% of the unit. The learning targets today are, I can explain why a segment parallel to one side of a triangle divides the other sides proportionally, and as well, I can find scale factors and use them to solve problems. All right, so there are 4 activities today. Let's start with activity 1. Does a line parallel to one side of a triangle always create similar triangles? Draw some examples. Decide if the conjecture is true or false. So why don't you take a minute and try activity number 1. So you can pause the video now and go for it. Okay, hopefully you guys paused it and you had a chance to try. Let's just draw some examples. So if this is your triangle, okay, draw a line that is parallel to one side. So I'll make that this line. So this and this are parallel. So it's asking if you create similar triangles. So the question is asking, is this one similar to this bigger one? Okay, or you could have drawn that line outside. So if you have a triangle, you could have drawn that parallel side outside. So there's a lot of different ways you could have drawn it. All right, but to decide if the conjecture is true or false, I guess it depends where you're drawing the line. But if we move down to number 2, find any additional information you can be sure is true, label it on the diagram. So this is what it could be one of the triangles you drew above. And so if we know that line AC is parallel to line MN, that's given. Hopefully you remember, if you have parallel lines, then corresponding angles are congruent. So this one and this one are congruent. This one and this one will be congruent. Yeah, so those are a few pieces of information you should know, and that's from last year. So 2 parallel lines with a transversal going through it. So if you have 2 parallel lines with a transversal, a line going through it, it creates corresponding angles that are congruent, vertical angles are congruent, consecutive angles are supplementary, etc. So that's something from last year. Write an argument that would convince a skeptic that your conjecture is true. So line MN is parallel to line AC with transversal AB. So corresponding angles are formed. So basically we know that in this green triangle, and then as well as this pink triangle, we have AA similarity. Angle A is congruent to angle BMN, and angle C is congruent to angle BNM. All right, so what we did was we proved that a line parallel to one side of a triangle creates 2 similar triangles. And if you have 2 similar triangles, that means that it splits the sides proportionally. All right, because remember the side ratios are the same. So when we have this parallel line right here, that means that BM over segment BM over BA is equal to BN over BC. Or you could say BM over MA is equivalent to BN over NC. There's a few different proportionality statements that you could write. All right, but that is activity numero uno. All right, so let's move on to activity number 2. And after you finish activity 2, try to do the Are You Ready for More if you have time. But pause the video now and try activity number 2. All right, so here, find the length of each unlabeled side. So we need to find first AB. So the line segment AB, okay, we know that ABD, triangle ABD is a right triangle. So we can use the Pythagorean theorem. So AD is 3 squared plus BD, 4 squared, is equal to AB squared. So AB is going to be equal to 5. All right, and then DF. So we know that because AB and EF are parallel, it splits the sides proportionally. So dA over dE will be equivalent to dB over dF. So dA is 3, dE is 7.5 is equal to 4 over dF. So if you do cross multiplication, you're going to get 3dF is 30, so dF is going to be 10. If dF is 10, then BF will be 6. And then EF, so if we want to find out EF, we can do Pythagorean theorem because we know that this side is 7.5. We know that this side is 10. Or what we can also do is figure out the scale factor. So to go from 4 to 10, the scale factor is new over old. So the scale factor is going to be 10. 10 is the whole thing over 4. So the scale factor is 2.5. So if AB is equivalent to 5, multiply 5 by 2.5, and then EF will be 12.5. So those are the missing sides. Okay, there's so many different ways you could have solved it. Your way could have looked very different from mine. But they're all correct. All right, so for question number 2, we know that BD and FG are parallel, and that is some important information because then we know that triangle EBD is similar to triangle EFG because of angle-angle similarity, right? Because if they're parallel, corresponding angles are the same. And then this angle is the same. And so by angle-angle, we know that those two triangles are similar. And if they are similar, then we know that the side ratios are proportional. So if FG is 15, the scale factor is going to be 3. Because this side is 5, and then it triples, so it's going to be 15. So we have to find the length of each unlabeled side. So we need to find BE, we need to find DE, we need to find FB, and we need to find GD. Okay, so we know that segment EG, this whole thing, is 12 units. Segment EB is 2.5. So remember, this is a scale factor of 3. So if BE is 3.5, then the entire thing is going to be triple that. So EF is going to be 7.5, which makes BF actually 5. Okay, so BF or FB is 5. BE is, EB is given to us, 2.5. We didn't need to find that. And then DE, we don't know what it is, but we know that this whole thing is 12. So if the whole thing is 12, so we'll say EG over ED. So we're taking this whole blue part divided by this black part. It's going to be the same as this whole blue part, the whole thing, divided by the black part. Okay, and so then you're going to get EG over ED is equal to EF over EB. And then fill in the missing values. So EG we know is 12. ED we don't know. EF is 7.5. EB is 2.5. So if you cross multiply, you're gonna get a value of ED is equal to 4. All right, and that's the same as DE. And then DG, if ED is 4, then DG will be 8. Okay, so you're just setting up ratios to find missing sides. Activity number 3, we'll skip that one. A lot of those are going to be coming back in activity 4, so let's just jump straight to activity 4. Here is a quilt design made of right isosceles triangles. The smallest squares in the center have an area of 1 square unit. So that means that this is 1, this is 1, this is 1, this is 1. Find the dimensions of the triangles. Okay, so what that means is that this is 1. If it has an area of 1, it means that the side lengths are all going to be 1. So this side length is 1, this 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 is 1. So that means that this side length, whole thing, is going to be 2. This whole thing is 2. This whole thing is 2. This whole thing is 2. And then from there, if we know that this is a right triangle and they are the same sides, I'm going to call this A and A. So take a look at this right triangle right here. I'll fill it in pink. That triangle, so we know that A squared plus A squared will be 2 squared by the Pythagorean theorem. So 2A squared is 4. So A squared is 2. A is going to be plus or minus root 2. But distance can't be negative, so A is root 2. So all of those sides are root 2. So this is root 2, 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 root 2. And then, so the whole thing is going to be 2 root 2. So this whole length is 2 root 2. And then if you want to find these side lengths, again, it's a right triangle. So let's call this A and A. Or let's use a different letter, B and B. So B squared plus B squared equals 2 root 2 squared. Right? Pythagorean theorem again. 2b squared is equal to 4 times 2. So b squared is 4, b is going to be 2. So that means that all of these sides are 2, 2, 2, 2, 2, 2, 2, 2. And then for the largest triangle, the hypotenuse is 4. So let's say this is C and C. So c squared plus c squared equals 4 squared. 2c squared is 16, c squared is 8, c is root 8. So all of these sides are root 8. Okay, that was a lot of work for question number 1, but you're basically using Pythagorean theorem and you're working from inside out. All right, are the triangles similar? If so, what are the scale factors? Yes, they are similar. They are all right isosceles triangles. So all of the angles must be the same. If you have 2 triangles and they both have right angles and these 2 are the same, right? Then we know that no matter the size, like even if I enlarge this, it's going to be the same. The angles will be the same. What are the scale factors? All right, so the scale factor from the small to the medium, it's going to be, or the medium to the large, it's going to be root 2. So let's take a look at this triangle, this green one. I'll make it this pink one. So that pink one has root 2, and 2. And then the larger green one, I'll do that in brown, or the larger red one. That's going to be 2, 2, 2 root 2. So if you're looking for the scale factor from small to big, it's 2. So we'll take one side, 2 divided by root 2. Or you can use the hypotenuse. You can say 2 root 2 over 2, and that gives you root 2. This, if you simplify it, also gives you root 2. So the scale factor is going to be root 2. All right, and this is the last question of the day. So this is activity 4, number 3. So this quilt is meant for a baby. To make a quilt for a queen size bed, it needs to be 90 inches wide. So we're going to set up a ratio. What we need is for this entire width here to be 90. And what we're looking for is this little one here, the right side of that. So currently for the small quilt, the small one, the one we currently have, we have 1, which is this one, over 2 root 8, because the entire width is root 8 plus root 8, which gives us 2 root 8, is equal to, and then this is the large one, the one that we're going to make for the queen size bed. So x is what we want to know, because we want to know how big the square or the side length will be of the small square. And then on the bottom we have 90. So then when you multiply both sides by 90, we're going to get x equals 90 over 2 root 8. So that's 45 over root 8, and that gives us approximately 16 inches. Roughly, I believe it's like 15.9 or 16.9 or something, but you can try the math yourself. And that is it for the lesson. You can go ahead and start on the homework. If you want, you can try the Are You Ready for More? And as always, email or chat me if you have any further questions. All right, good luck, and I'll see you next time.